This assignment related to momentum questions, as we discussed a few questions yesterday. This question, part B, yesterday we calculated how to work out the velocity, but to reach the goal, the disk must move up a ramp at an angle of 30 degrees to the horizontal. The velocity of the disk at the bottom of the ramp is 5. The disk move up the ramp and the work done by the disk against the friction, and the disk move a distance 6.5 centimeter up a ramp before moving back downward. We have to determine the frictional force, and it is of 6 marks. So how we can work out the frictional force, the force which is opposing the motion? So what we will do, basically, here what happened, the kinetic energy is converted into potential energy and work done against the friction. As at the beginning, at this point, it is having a kinetic energy. Then when it is moving on this inclined surface, there is work done against the friction. Some of the work done against the friction, and at this point it will have a potential energy. So we can write the equation, we can write that kinetic energy is actually equal to work done against the friction plus the potential energy. So the kinetic energy is equals to half mv square. So we will solve each part individually, and then we can substitute in this equation to get the final answer. So first, about the kinetic energy. So the kinetic energy is half mv square. What about the mass? That is mentioned in the question, that the mass of this disk is 0.035, that was mentioned in the first part. And so 0.035 times the speed at which it move on inclined surface initially, that it reaches at 5, so speed is 5, so it will be square. So what will be the kinetic energy when we substitute? It will be 0.44 joules. Now for potential energy and about the work done, so this work done against the friction, so work done is equals to force into distance. So the force which we are finding, and what about distance? So length of the inclined surface, what is the length of inclined surface? That is given in the question, that the disk moves a distance 6.5 centimeter up a ramp. So this is the distance move, which is 6.5 centimeter. So this is 6.5 centimeter, and we should always use distance in meters, so it will be 0.065. So work done will be equal to force, we don't know, and the distance will be equal to 0.065. Then what about the potential energy? And at the last we'll substitute in this equation. Potential energy is mgh. So we have the mass, which is 0.035, we have gravity 9.81, but what about this height? So we have to use a right angle triangle for this. This is 6.5 and 30, so this will be 6.5. The component which is with that angle, that is with cosine theta, so this will be 6.5 cos theta, and this is against the angle, so 6.5 sine theta. So the height is actually 6.5 sine theta, or you can also say 0.065 sine theta, because it should be in meter. So that is multiplied by 0.065 sine 30. So when we substitute, we'll get the potential energy. that will come out as 1.12 into 10 to the power minus 2 joules. Now the equation, we know the potential energy, the kinetic energy is basically transformed into potential energy plus work done. Kinetic energy was 0.44. The potential energy is 1.12 into 10 to the power minus 2 plus the work done, that is force into distance, which is 0.065. So 1.1 exponent minus 2 will move other side and that is divided. So we'll divide 0.065, so we'll get the force, which is about 6.56 newtons. Is it clear, this question? That how we work out that the frictional force which is opposing the motion can be calculated. Question 4 and 5 we already discussed. Question 6, the diagram shows the velocity of an object before and after. The magnitude of velocity did not change, means the value does not change. Which of the following represent the direction of change in the velocity? What is the meaning of change in velocity? It means final minus initial. So basically, if this is u, this is v. What we have to calculate? We have to calculate v minus u, that is the change in the velocity. So in terms of vector addition, first we'll draw, because it is v minus u. So what is the meaning of v minus u? It is like v plus and then minus u. Means we'll add vector v to vector minus u. So what is vector v? This is vector v. We draw in the same manner. What about vector u minus u? Because if the u is upward, the minus u will be downward. And it must be done with a calculation, like using a ruler. You will measure these lengths. As I mentioned, that magnitude is represented. So we have to use a ruler or scale to measure the length to work out the exact number. So this is u, and then we have to add minus v. So minus v will be in opposite direction. And what is the resultant from tail of the first to the head of the last? That will be the resultant. So in this example, B will be the right answer. Is it clear, this question? Because they asked for change in the velocity, so there should be. How to know which direction? That's because from the vector addition rule, the tail of the first to the head of the last is a resultant. So the initial velocity was given. This is, the diagram shows a velocity of an object before and after. So the before velocity is called u, and after velocity, the final is called v. We need the change in the velocity. Change in velocity means v minus u. So in vector addition, what is the meaning of v minus u? It means v, then minus, it's like addition plus, and then minus u. So you have to measure these lengths. Like if the both are not appearing to be same in size, say this is 2 centimeter, this might appear as 2.3 centimeter. So to get the vector addition, first it is v, then u is upward. So what is the direction of minus u? Minus u will be in opposite direction. So this is minus u, and the resultant is always from tail of the first to the head of the last. That will be the resultant. So that's why B is the right answer. Is it clear? Question 7. Trolleys are shown here. You can see trolley X and Y. One is having a mass of m, another one is having a mass of 3m. Both are moving with the same speed. The trolleys collide and move off together. Which of the following statement is correct? The first two statement cannot be right. Why the first two statement cannot be right? Because when object collide, according to Newton's third law, forces always act in pair. If X is exerting a 30 Newton force on Y, so the Y should also exert same force on X. So force of X on Y during collision is greater, or force of X and Y during collision is less than force of Y on X. So these two statements are totally wrong, because whenever object collide, the force exerted by X will be same as force exerted by Y. The only difference that the direction will be opposite. Now the trolley X and Y of masses m and 3m are moving at the same speed towards each other. So the speed of X after collision, so what happened? The mass of X is how much? It is m. And what about the mass of Y? This is 3m. So according to conservation of the momentum, the total momentum before collision should be equal to total momentum after collision. As I mentioned, they collide and move off together. So we can say the sum of the momentum before is equals to the momentum after collision. So what about the momentum before collision? If we consider any one of the direction, you can consider positive. If our right hand side I consider as positive, the left hand side will be negative. So momentum before for this one is mv, and for this one is minus 3 mv, because the mass is 3m. So total momentum is mv minus 3 mv is equals to momentum after collision. So as I mentioned, after collision the two trolleys stick together and they move off together. So if they move off together, both will have the same speed. So the mass of the first trolley, the trolley X, is m, and its velocity is say x, that is unknown, and the mass of the second trolley is 3m, and its velocity is also x, because both of them moving together, so it means both will have the same velocity. So m minus 3m is mv minus 3mv, so that is equals to minus 2mv. If we take m common here, so m is equals to, or m into x plus 3x. Or you can even directly add mx plus 3mx. That will give us the 4mx. M will cancel with m. So minus 2v is equals to 4x. Or minus 2v divided by 4 is equals to x. Or x is equals to minus v by 2. What it shows? Negative sign shows that they will move, like compared to original position of the trolley, they will move towards left hand side, because positive direction we consider as right and negative is left. So both will move towards left. And what about the velocity of each trolley? The velocity will be v by 2. So if original velocity was v and now the velocity is v by 2, so what we can say, the speed of x after collision will be less than v. That's why D is the right answer. Is it clear, this question 7? In question 8, a popcorn kernel contains water. When heated, the water turns into a steam and the kernel pops, moves upward. The photograph above shows a popcorn kernel just before being popping and a maximum height after it pops. Determine the maximum height after pop. So the scale is given. What you can do, you can use, like they mentioned, this is 1 centimeter. So you'll place your ruler or a scale and measure this distance. So example, when you place your ruler or the scale next to this, it appear, example, it is 2.5 centimeter, example. So what it shows that the figure size, 1 centimeter of the figure size is actually 2.5. So figure size and the actual size, the relation is 1 centimeter of the figure size is equivalent to 2.5 centimeter of actual size. And then we need this height. So using a ruler, we can take the point. We'll measure this height h using a scale or a ruler, and then example we measure in on the figure. It can be any number. So if this figure size is coming out, say 2 centimeters, so this will be x cross multiply. So it will be 2.5 into 2. So the figure actual size will be 5 centimeter. I just use the number here. Because I don't know what will be the value. This will vary according to the paper size, but this is the technique we will use to work out to find the figure comparison of the figure size with actual size. Is it clear, this idea? So you will find these type of questions are very common, in which you have to work out the scale from different photographs. Calculate the initial speed of the popcorn kernel. So we want to find the initial speed. We have the height. So if we know the height, we will assume the potential energy. The kinetic energy is equals to potential energy. There is no change. So example of this height, it can be any number, but it's according to your answer, you will write that measurement. But actually it should be 3.4 centimeter, or we can say 0.034 meters. So here it will have a kinetic energy, and when it reaches the height, the kinetic energy transformed into potential energy. So we can say the potential energy is equals to kinetic energy, or the change in the kinetic energy is equals to potential energy. Kinetic energy is half mv square, and potential energy is mgh. M will cancel with m. So V is equals to GH, 2GH. We need V, so it will be under root 2GH. So 2 multiplied by 9.8 multiplied by 0.034 in a root, we'll get the speed at which this pop kernel move, the initial speed. That will come out as 0.82 meter per second. The next part, the average water content in a popcorn kernel is 14% of the total mass. So 14% of the mass is the water, and remaining 86% is the corn. A kernel is heated until it pops, steam is ejected downward, and the popcorn kernel moves upward with the initial speed of 1.5. Calculate the speed at which the steam is ejected. So we'll use the conservation of the momentum when something pop or explode. The initial momentum is 0. So if this was the unpopped kernel, so when it pop, it ejects water, means part the water will come out, which is downward, and the kernel will move upward, the pop kernel, with a velocity of 1.5 meter per second. We have to calculate the velocity at which the steam is ejected. Now, what about the total mass is 0.11 gram, and this 14% is actually water, the total mass, 14% of this mass, and 86% is the corn. So the mass which is ejected upward, that is 86% of 0.11, and the mass, the water molecule which are moving downward, that mass is 14% of 0.11. So we can work out the mass here first, and after that we can use the conservation of the momentum, that momentum before will be equal to momentum after. So when we work out 86% of 0.11 gram, so that will be 0.0946 grams. And what is the mass of the water which is ejected? So 14% of 0.11 gram, so that is equals to 0.0154 gram, and I can convert into kilogram. But when we are dividing the two values, we don't have to convert the unit because it does not make difference to the final answer. So according to conservation of the momentum, the total momentum before collision is equals to momentum after. What is the momentum before? Because initially it is at rest before it being popped. So final should also be 0. Mass into velocity is equals to mass into velocity, but if one is moving up, the other one is moving down. So if one of the momentum is positive, the other one will be negative. So it will be mass 0.0946 multiplied by velocity 1.5 plus the mass is 0.0154 into velocity, because if this is positive velocity, this will be negative. So we'll write as minus v. And we just solve the equation. So speed at which this water will come out, that is 9.2 meter per second. And you can convert the mass into kilogram. It won't make difference to the final answer because you have to divide the two values. Is it clear, this part? Any doubt in part B? The next one, an object of mass 50 kilogram accelerated uniformly from 2 meter per second to 10 meter per second in the same direction, the impulse provided to cause this acceleration. So how to impulse means the change in the momentum. So you can calculate impulse by two ways. It is mass into velocity final minus initial. As the direction does not change, same direction, so both are positive. So what is the impulse? The mass is 50 and the final velocity is 10, minus mass is 50 and the initial velocity is 2. 500 minus 100, that's equal to 400 kilogram meter per second, or you can also say Newton second. The next one, a bullet of mass 0.1 kilogram traveling horizontally at a speed of 600. So there's a bullet which is moving at a speed of 600 meter per second, it collide a block of mass 1.9 which is at rest, and the bullets stay in the block. So basically after the collision they are moving. When something stick together or stay, so means both are moving with the same speed. You can say x, you can say v, that does not make difference to the final value. So momentum before collision is equals to total momentum after. The mass of the bullet, that is 0.1 kilogram. It was moving with a speed of 600 meter per second. The mass of the block, that is 1.9, but it is initially at rest. So this is 0 0.1 and this is 1.9 kg. Both are moving together. So the conservation of momentum, the momentum before collision, the sum of the momentum before is equals to sum of momentum after. So 0.1 multiplied by 600 plus 1.9 multiplied by 0, then that's equal to 0.1 into x plus 1.9 into x. So 0.1, that is 60 plus 0 is equals to 0.1x plus 1.9, so the sum will be 2x. Or it will be 60 is equals to 2x, so x is equals to 60 divided by 2, so x is 30 meter per second. So the momentum will be 30 meter per second. That's why A will be the right answer. In question 11, an object of mass 60 kilogram, it decelerates from 50 to 20. The resultant force is 300. Act on it. How long does the force act? So first we'll calculate the impulse, the change in the momentum, and then we relate, because we know impulse is equals to mv minus mu, and we know impulse is also force into time. So if we compare, we can say force into time is equals to mv minus mu. If the direction does not change, both of the velocities, the magnitude will be positive. The force is 300, time we don't know. The mass is 60, the final velocity is 20, minus the mass is 60 and the initial velocity is 50. So 300 t is equals to 6 multiplied by 2, 12. So that will be 1200, and 6 multiplied by 5, that's 30, so it will be 3000. 1200 minus 3000, that is equals to 1800. So when we are finding a time, it is 1800 negative, and that is because force will also be negative, that's minus 300. So when we simplify, it will come out as 6 seconds. Is it clear discussion that how long the object force act on the object to change the momentum? Then a ball is moving with a momentum of 25. It collide, so the initial momentum is given 25 kilogram meter per second. The ball bounce off with the same speed, but when it bounces off, it changes the direction, and when the direction changes, the momentum also change. So even the direction change, there is a change in momentum, so that is minus 25 kilogram meter per second. And for 50 millisecond, it come in contact for 50 millisecond. We have to calculate the force. So impulse is equals to force into time. Impulse is a change in the momentum. So it will be 25 minus 25. And it's up to you. If one of the value you took as negative, the other one will be positive. and that is force multiplied by time is 50 millisecond. So it will be 15 to 10 power minus 3. So 25 minus minus plus, so that will be 25 plus 25, 50, and F into 50 millisecond. This is multiplied, other side will be divided. So what is the value of the F? It will come out as 1000 Newton. Is it clear? So these are some questions related to topic momentum. I will share this assignment with you.